Okay, so in this section, we're going to talk about some other types of equations. So far we've talked about linear and quadratic equations, and in this one, we're going to kind of look at some other types of polynomials, maybe some radical functions, so that means things with square roots, perhaps. So let's take a look at some examples. First of all, polynomial equations. Okay, a polynomial equation is the result of setting two polynomials equal to each other. So it's an equation with polynomials. Seems good enough, all right? So the general form is where one side is 0 and the polynomial on the other side is in descending powers. So it means you start with the biggest exponent and you work your way down until you have the constant at the end. And again, the other side has to equal 0 to be in the general form. Now, the degree of a polynomial is the value of the largest exponent. So, for example, if I had f of x equals 5 minus 3x to the 6 plus 4x squared, well, first of all, that's not in general form. So I can put it in general form by putting the biggest exponent first and the constant at the end. And when I do that, I can see that the biggest exponent is indeed 6. So that is the degree of this polynomial. All right, so how do we solve polynomial equations? Well, it depends. If we have something like this, we are going to solve it by factoring. So first of all, remember I want to move everything over to one side. So I will have my 2x cubed and my 3x squared, but then I'm going to subtract 8x and I'm going to subtract 12 to the left. Now it equals 0, so I can solve it by factoring, which is good for us. All right, now what kind of factoring do I have to use when I have 4 terms in a polynomial? Well, it's pretty much going to be grouping. So I'm going to look at these first two, and I'm going to say, okay, I can pull an x squared out of both of those. And when I do that, I'm left with 2x plus 3. Now I look at my next two, and I say, all right, I'm going to pull out a negative 4 from both of those, and that also leaves me with 2x plus 3. And that's our hint that we've done it correctly, is that the two sets of parentheses match. Because now I want to pull out the parentheses from both. So I'm going to pull 2x plus 3 out from both terms, and that leaves me with x squared minus 4. Now, don't be tempted to stop here, because you can factor further. That x squared minus 4 is of the format a squared minus b squared. And if a squared minus b squared is a plus b, a minus b, then x squared minus 4 is x plus 2, x minus 2. Now looking at this, we can use the property where you have the three things multiplied equals 0, or any things multiplied equals 0. At least one of them has to be 0 itself. So I can say 2x plus 3 equals 0, and that happens when x equals negative 3 halves. I can say x plus 2 equals 0, and that happens when x equals negative 2. Or I can say x minus 2 equals 0, and that happens when x equals positive 2. So I have three answers: negative 3 halves, negative 2, and 2. All right, let's talk about radical equations now. A radical equation is any equation that has a square root, a cube root, a fourth root, a fifth root, in other words, a root of some sort, okay? We're going to mostly be working with square roots, but know that these other types of roots are perfectly valid and can come up anytime. We're going to solve them by raising it to a power that matches the root. So if it's the square root, we're going to square both sides. If it's a cube root, we're going to cube both sides. If it's a fourth root, we're going to raise both sides to the fourth. If it's a fifth root, raise it to the 5, so on and so forth. So we solve radical equations with nth roots by raising it to the nth power. All right, but what you do to one side, make sure you always do to the other as well. So we are raising both sides to that value. So let's take a look at the steps. 1, we need to arrange terms so that one radical is isolated on one side of the equation. So isolate a radical. There may be more than one radical involved, but you have to isolate one of them at a time. Then we're going to raise both sides to the nth power. So if it's the nth root, the nth power, okay? And that's going to get rid of the root that we isolated. Then we're going to solve the resulting equation. We may need to loop back through these steps. So if there's still a root left over, you're going to isolate it, go through the steps, and you're going to keep repeating that until it's a rootless equation and you can solve it. So let's look at an example of that. Oh, sorry. One last step. Make sure to check your solutions. One of the things about radical equations is that you're going to have situations where sometimes you'll have an answer that isn't actually valid. It's extraneous or erroneous. Extraneous means extra, and erroneous means in error. So it's a wrong solution. So always go back and check it, and that means you actually have to plug it back in, and you cross out any solutions that do not work, and you box any solutions that do. All right, now let's look at this example. So first of all, we need to isolate the radical. Notice that this is the root of x plus 3 plus 3. So since that plus 3 is outside of the root, I can move it, and so I will. So now I have the square root of x plus 3 equals x minus 3. Now, to get rid of the square root, I need to square both sides. One of the things you have to remember, though, is when you square that side, you're squaring the whole other side. So you do have to put parentheses around to the right side of the equation before you can square it. Now, the left side, the square and the square root have canceled, and I'm left with just x plus 3. And on the right side, remember that you cannot just square the pieces, okay? You have to write out x minus 3 times x minus 3, okay? Because it's squared, it gets written out twice. And you'll need to FOIL it. If you just square the pieces, you'll miss out on the middle term, which messes up the whole equation. So remember, write it out twice instead. Now I carry down x plus 3, and I'm going to FOIL. And when I FOIL, I have x squared minus 3x plus 9, or x plus 3 equals x squared minus 6x plus 9. Now, I do need to move everything over to one side because we now have a quadratic, and quadratics have to equal 0 to be solvable. So I subtract x, I subtract 3. That gives me 0 equals x squared minus 7x plus 6. Now, if it's factorable, I should factor it. If it's not, I'll do quadratic equation. In this case, I can factor it. I need to find two numbers that multiply to 6 and add to negative 7. And I think to myself, well, negative 6 and negative 1 seem to fit that bill. So I'm getting two answers, x equals 1 and x equals 6. Now, I still have to check and make sure they both work. So I'm going to check each of them. So check x equals 1. So I have the square root of 1 plus 3 equals 1, question mark. So this is the square root of 4 plus 3 equals 1. This is 2 plus 3 equals 1. That's 5 equals 1, which is not true. So 1 is not a valid answer. Okay, so we're going to get rid of that. So now let's check x equals 6 as well. So we have the square root of 6 plus 3 equals 6. Square root of 9 plus 3 equals 6. 3 plus 3 equals 6, and of course 6 does equal 6. So x equals 6 does work. So x equals 6 is our only answer because 1 did not. So see how important it is to check our answer at the end? All right. So let's talk about equations with rational exponents. A rational exponent is an exponent that includes a fraction and variables, or fraction and numbers. So in this case, we have x to the m over n, and this gives us the nth root of x to the m. So it's important here to notice that it's the denominator that tells us the root, okay? and it's the numerator that tells us the remaining exponent. Okay, so keep that clear on your paper. Color coding is a great idea. All right. Then I can use that to help me simplify a lot of things. All right, so we can go from one format to the other, and that can be really helpful to us. So if we have a radical equation with rational exponents, we can isolate the piece that has the rational exponent and raise both sides to a power that is the reciprocal of the rational exponent. So just like with the square root, we squared both sides, and with the cube root, we would cube both sides, and the fourth root, we'd raise both sides to the fourth. Okay, this time we're going to raise both sides to the reciprocal of the exponent. So for example, all right, let's say I had x to the 2/3 equals 4. Okay, my exponent is 2/3. So I'm going to raise both sides to the reciprocal of that, which is 3/2. Like that. Now, because, hopefully you remember, x to the a to the b equals x to the ab, 2/3 and 3/2, when I multiply them, well, 2/3 times 3/2 is 6/6, which is 1. So that becomes x to the 1 equals 4 to the 3/2. Now, I can write 4 to the 3/2 in its radical notation, which will make it a little bit easier for me to work with. I see 2 as my denominator, so that's a square root of 4. And then it's up to you whether you want to put the 3 inside the radical or outside. I like it outside here. Keeps it out of the way for a moment. Then I do square root of 4 is 2, and 2 cubed is 8. So you can see that doing the reciprocal and raising both sides to that number can help simplify our equations as well. So let's take a look at a very similar example. I want you to go ahead and start by isolating the part with the rational exponents, and then try and raise both sides to the reciprocal, and then try and convert it into radical format. Give it a go. Okay, so let's talk about isolating first. I'm going to add 25 to both sides. Then I'm going to divide by 5. Now the thing with the rational exponent is by itself, and I can raise both sides to the reciprocal. In this case, the reciprocal of 3/2 is 2/3. And so I end up with x equals 5 to the 2/3, or if it wants in a radical notation, we would write as the cube root of 5 squared. Now, again, you can write this with the squared inside if you prefer. And you could even write this as the cube root of 25 if you like. All of these are equivalent. So just pay attention to how the question asks you to answer it. Okay. All right, let's talk about equations that are not quadratic, but they are like a quadratic. We say that they're quadratic in form. Okay, it's one that can be expressed as a quadratic equation if we were to substitute something in. All right, so that sounds a little weird, but you'll recognize the ones that are like this. Okay, so for example, this one, when they say substitute something in, they're saying, let's say y equals x squared and y squared equals x to the 4th. Then I could write this as y squared minus 5y plus 6. Now it's a quadratic, so I can factor it, and I can say, all right, I need two numbers that multiply to 6 and add to -5. Well, I'm going to go with -2 and -3. Don't be tempted to use -6 and 1 because those multiply to -6, and we need this to multiply to +6. Okay, so then I get that y equals 2 and 3. But I want to point something out to you that really what we've done here is we've said that x squared equals 2 and 3. This is important, okay? So either x squared equals 2 or x squared equals 3, and then I need to finish solving for x. So I take the square root, and I get x equals plus or minus root 2 and plus or minus root 3. Okay, now a lot of times we're going to just jump straight into, if we're given this formula, we'd write it as x squared minus 2, x squared minus 3 equals 0, and factor it straight into that, and that is fine as well. At which point you would still set each thing equal to 0. You'd get x squared equals 2 and x squared equals 3. So either way you want to show me the work, just make sure you show your work. All right, let's talk about things that involve absolute values. Absolute value of a number is the distance it is from 0. So the absolute value of a positive number is going to come out the same number exactly. And absolute value of a negative number is going to come out to the positive version of that number. So, for example, I know that the absolute value of 4 is 4, and I know the absolute value of negative 4 is also 4. So if I ask for the absolute value of x equal to 4, and I say, okay, what number or numbers could I plug in for x so that I get 4 out? Well, you look at this, I plugged in 4 and negative 4, both worked. So I could say x equals plus or minus 4. So one of the key things here is if you have the absolute value of u equal to c, then you could be c, or you could be negative c. Note that you are changing the other side of the equation. You also have to have the absolute value isolated to use this rule. So let's take a look at what that means in this context. First of all, is the absolute value by itself? Well, here's my absolute value. On the left side of the equation, there is nothing else on that side of the equation. Therefore, I can go straight into saying 2x minus 1 equals 5, or 2x minus 1 equals negative 5. I want to be really clear. This does not mean, the absolute value does not mean you can change the middle sign. I know a lot of people, they want to make it 2x plus 1, but this is not what it's saying. It's saying 2x minus 1 equals, the other side could be 5 or negative 5. So you're changing the sign of the other side. All right. Now, I'm going to add 1 on both sides and divide by 2. That gives me x equals 3. I'm going to do the same thing for the other one. So add 1, 2x equals negative 4, divide by 2, x equals negative 2. Now, I put my little or in between. It's important to say or. And then you do want to check your answer. Absolute value equations, like radical equations, can occasionally give you extraneous or erroneous solutions. So you do want to check that your answers work. Okay? So let's start by checking x equals 3. So I have absolute value of 2 times 3 minus 1 equals 5. That's the absolute value of 6 minus 1 equals 5. Absolute value of 5 equals 5. That's true. I can also check x equals negative 2. That's the absolute value of 2 times negative 2 minus 1 equals 5. That's the absolute value of negative 4 minus 1 equals 5. Absolute value of negative 5 equals 5. And that is true. So they do both work. We get to keep both. Yay us. Ta-da! All right, let's look at an application of why we're using equations that aren't just lines or just quadratics. Where else would we see things like this, where it's radicals or whatnot? Well, one of them is this formula here, h equals negative 2.3 square root of I plus 67.6. It's talking about how much the weekly television viewing time in hours is based off of your annual income I in thousands of dollars. And then we want to figure out how much does someone earn in a year if they have 33.1 hours per week watching TV. So let's take a look and see what we can find out. All right, so first of all, 33.1 hours. We know hours is the h value. So we're going to plug 33.1 in for h. Now this is a radical equation. That means that I need to isolate the root. So in this case, I'm going to start by subtracting 67.6 from both sides. This is going to cancel over here. And I'm going to end up with, I believe it's negative 34.5 equals negative 2.3 root I. Now, I'm going to divide both sides by negative 2.3. And this would be a calculator problem, just so you know. So if you bring up your calculator, okay, this one comes out not totally terrible, but you will recognize that a negative divided by a negative should come out to be a positive. And look at that, it actually comes out beautifully. It comes out to exactly 15. Now I need to get rid of the square root. So I square both sides, and I have I equals, well, what's 15 squared? Well, hopefully you already know this, but it comes out to be 225, I believe. Yeah, there we go. All right, so then we need to make sure that we can write a sentence. So someone who watches 33.1 hours per week of TV is going to earn, well, it's not $225, okay? We're talking about thousands of dollars. So make sure you're able to translate this into that sentence that they're earning $225,000 in this case. Now, is this the actual number that's involved? I have no idea. I don't know if this is the formula or during what year this was true. But there you go. Now you know. All right. So let's take a look at another couple of practice problems. I want you to use the zero product principle and factoring to solve this polynomial equation. Remember to move everything to one side first, because you can't use the zero product principle unless one side equals 0. Okay, so I start by subtracting 36x and 36 over to the left side. Then I'm going to factor by grouping. The first two, I can pull an x squared out, and that leaves me with x plus 1. The second two, I can pull out minus 36, and that also leaves me with x plus 1. Now, I'm going to be able to factor x plus 1 out of both, which leaves me with x squared minus 36. And remember, we have to finish factoring here. So I'm also going to factor x squared minus 6 to be x plus 6, x minus 6. Since all three of these multiplied together equals 0, I can set each one individually equal to 0 by the zero product principle and get negative 1, negative 6, and 6 as my values of x. Solve this radical equation. So for radical equations, make sure that you isolate the root first. So in this case, the square root is the only thing on the left side, which is really nice. So I know, first of all, it's a square root, so to get rid of it, I'm going to square both sides. But remember that on the right side, that means I do have to put parentheses and make sure I square the whole thing. Now, the left sides become x plus 6, and the right side is x minus 6 squared, which is x minus 6 times x minus 6. So now I have x plus 6 equals, and when you FOILed this, you should have gotten x squared minus 12x plus 36. Now I'm going to move my x and my 6 over to the right side, and I get x squared minus 13x plus 30. And then I want to see, is there any way to factor this? Well, I can find two numbers that multiply to 30 and add to negative 13, and they are negative 3 and negative 10. Now I get two answers, x equals 3 and 10. But remember, do not box them both until you've checked that they actually work. So let's check those. Let's check x equals 3. I have square root of 3 plus 6 equals 3 minus 6. Don't forget your question mark. Square root of 9 equals negative 3. 3 equals negative 3 is not true, so x equals 3 is not valid. Let's check x equals 10. Keep in mind, guys, just because one works and one doesn't, some of the time, doesn't mean that's always the case as well. It's possible for them both to work, and it is possible for one of them to work, and it is possible for none of them to work. So you always do have to check both. If one doesn't work, don't assume the other one automatically does. I mean, most of the time it should, but you do have to check both. All right, so square root of 10 plus 6 equals 10 minus 6. Square root of 16 equals 4. Well, 4 does equal 4. Yay! So x equals 10 is the answer we can keep. Now, this radical equation is one of the ones where you're going to have to repeat the steps. So let me walk through the steps with you real quick. Isolate one square root. Square both sides. Isolate one square root. Square both sides. Solve. Okay, so I'm going to say that again. Isolate a square root. Square both sides. Isolate a square root. Square both sides. Solve. Try it. So first, I'm going to isolate this root 2x plus 3 by subtracting the root x minus 2 to the other side. Now, I can square both sides. You don't have to put parentheses there, but especially when I have lots of things going on, I put them in. All right, so this is 2x plus 3 equals 2 minus root x. Oops, sorry about that. Let's make that a minus there. Root x minus 2 times 2 minus root x minus 2. I carry down my 2x plus 3 again, and I FOIL. So I have 4 minus 2 root x minus 2 minus 2 root x minus 2. And then a negative times a negative is a positive. And root x minus 2 times root x minus 2 is root x minus 2 squared, which is x minus 2. So now I have 2x plus 3 equals, well, I have 4 and negative 2 give me 2. These together give me minus 4 root x minus 2. And then I have plus x. So remember, the next thing is to get the square root by itself again. So I'm going to subtract 2 from both sides and subtract x from both sides. And that gives me x plus 1 equals negative 4 root x minus 2. Now, technically, when I say isolate, you could take it as far as dividing by negative 4 on both sides here. Or if you want to go ahead and square both sides right now, you can. I'm going to go ahead and square both sides just because I'm trying to avoid my fraction. So I'm going to square here, and I'm going to square here. And note that when I'm squaring both pieces. Okay? So on the left side, x plus 1 squared, when you FOILed it out, should be x squared plus 2x plus 1. On the right side, you should have 16 and x minus 2. If you didn't get this far, go ahead and pause the video, catch up, and finish solving this. All right, so when I distribute my 16, I get 16x minus 32. Then I have to subtract 16x and add 32 on both sides. That gives me x squared minus 14x plus 33 equals 0. Now, if I can, I should attempt to factor. Well, I need to come up with two numbers that multiply to 33 and add to negative 14. The good news is those are x minus 3 and x minus 11. So I get x equals 3 and x equals 11. Do not box your answer yet. If you did not check your answers, pause again and try that now. All right, I'm going to start by checking x equals 3. When I do that, I get square root of 6 plus 3 plus the square root of 1 equals 2. Square root of 9 plus the square root of 1 equals 2. 3 plus 1 equals 2 is false. So x equals 3 is not valid. I'm also going to check x equals 11. And in that case, I have 22 plus 3 under the first square root. And I have 9 under the second square root. So I'm really doing the square root of 25 plus the square root of 9. And I want it to equal 2. And you see I get 5 plus 3 equals 2. And I happen to know 8 does not equal 2. So when I do this, are there any correct answers? The answer is no. So there is no solution. So I warned you earlier, just because one doesn't work, don't assume the other one does. You have to check both. Check on both. All right, so now that we did all that work to find no solution, try finding this one. Remember to isolate, then raise both sides to the reciprocal. And if you can turn it into a radical form and simplify, do that as well. So in this case, I'm going to add 33 to both sides and divide by 3. And then I need to raise both sides to the reciprocal of the exponent. So I'm going to raise it to the 3/5. So I get x equals 11 to the 3/5. And again, just pay attention to how the question asks you for the answer. If you're doing this on MyMathLab, it's going to have instructions in a little blue set of parentheses by the answer box. Okay, so if you type in an answer and it tells you you're wrong, go look at the blue things, reread it. Okay, because it could be asking for rational format, or it might be asking you to turn it into radical format, which in this case would be the 5th root of 11 cubed. All right, attempt to find all the real and complex roots of this quadratic form polynomial equation. So first of all, we try and figure out, can we factor this? If I factor it, I'm going to have x squared minus 9 times x squared minus 6 equals 0. Now, x squared minus 9 does factor to be x plus 3, x minus 3, whereas x squared minus 6 doesn't factor. But now I'm going to set each thing equal to 0. So, I have x plus 3 equals 0, x minus 3 equals 0, and x squared minus 6 equals 0. So this is going to give me negative 3. This one's going to give me positive 3. This one I have x squared equals 6, so x equals plus or minus the square root of 6. So I have 4 answers. They're all real this time, but root 6 and negative root 6 are irrational. Okay. For this one, pretend like y equals x to the negative 1. So y squared equals x to the negative 2. And make that substitution, solve for y, and then use y to solve for x. Okay, so x to the negative 2 I said was y squared. X to negative 1 I said was y. So this is what this equation looks like now. I can factor to be y minus 6 times y minus 3. So I can say y equals 6 or y equals 3. But keep in mind that what I'm saying there really is x to the negative 1 equals 6 or x to the negative 1 equals 3. To get rid of the -1 in the exponent, so to solve for x, remember I'm raising both sides to the -1. So this gives me x equals 6 to the -1, which is 1/6. Or, I do this on the other side, I get x equals 1/3. Remember, a to the -1 is 1 over a. Try solving this absolute value equation. Remember to isolate the absolute value and then set what's inside of it equal to the positive and negative of the other side. Okay, so I'm going to divide by 3, and I get absolute value of 2x minus 1 equals 3. Now I can say 2x minus 1 equals 3, or 2x minus 1 equals -3. I can solve this first one, and I get x equals 2. And I can solve the second one, and I get x equals -1. Do remember to check your answer, okay? So if we check x equals 2, we'll have 3 times the absolute value of 4 minus 1 equals 9. 3 times the absolute value of 3 equals 9. 3 times 3 equals 9 is true. And we'll check x equals -1 as well. 3 times the absolute value of -2 minus 1 equals 9. 3 times the absolute value of -3 equals 9. 3 times 3 still equals 9. So yay, they both work. Congratulations to us. Good job.